Hazard perception is the ability of being able to quickly spot dangers on the road, and researchers have shown that drivers who excel in this skill are less likely to have collisions. If you've been driving a car for many years, you're probably pretty good at spotting hazards when out on the road. However, there are some hazards that even highly experienced drivers can miss. In this video, we'll talk about some of these most difficult hazards to spot and hopefully make you even safer on the roads. First, let's start by putting you into a hazard perception clip. You're going to be the car driver looking out for danger as you drive along the road. As you progress down this road, you're heading towards a T-junction where you intend to turn right. So what happens next? Any idea? Let's have a look at the full clip and see what the actual hazard was. As we were turning right, we get surprised by a motorcycle overtaking stationary traffic to our right. These sorts of collisions are a big problem for motorcyclists. Typically, they make up 1% of traffic on UK roads, but account for around 20% of all fatalities, and that doesn't seem very fair. So why do riders crash? The top reasons include rural bends, perhaps going in too fast, maybe underestimating the curvature and then losing control. But also, cars and vehicles fail to give way to motorcycles and pull out in front of them at junctions. Or they may change lanes without checking for overtaking or filtering motorcycles. In fact, more collisions are caused by the actions of other road users than by the motorcyclists themselves. So why do car drivers crash into motorcycles? Are these drivers unobservant, distracted? Do they have poor hazard perception skills? Well, all of these are possible, but even highly experienced drivers who are completely focused on the road and have otherwise great hazard perception skills can still crash into motorcycles. Why might this be the case? We're going to look at 3 of the key reasons that drivers might pull into the path of motorcycles. But first of all, we're going to start with a little activity. I'm going to show you a picture of a road scene, and I want you to find the dog. You've only got 5 seconds to find it. Are you ready? Here we go. Did you find the dog? Let's have another look and see where it was. Did you spot the dog in the tree? No? Perhaps the dog on the roof? Or maybe the dog on the other roof? Or even the dog on the windowsill? If you didn't spot any of these dogs, don't worry. That's what happens to most people. Let's have a look at a little video of someone searching that picture, trying to find the dog. You're going to see their eye movements on the screen, represented by little circles which show what they're looking at. And the lines joining those circles show when the eyes are jumping. As you can see, they're searching the pavements and the road, everything that is low down in this picture, and they failed to find the dog. So why didn't they and you not look in the tree or on the roof for the dog? Well, because dogs stay on the ground, it's common sense. If you want to find the dog in the real world, you look where you know a dog should be. In other words, our experience of the world guides where we look for dogs. In the same way, experience guides where we look for hazards on the road. We still have to learn where these hazards are going to appear before we know where to look. To see whether this applies to the first hazard video that we showed you, we asked 112 car drivers and motorcycle riders to watch that video while searching for the hazard. Now we've got 2 videos here, one showing the eye movements of a car driver and one showing the eye movements of a motorcyclist while they're trying to find that hazard. Can you work out which one of these is the car driver and which one rides a motorcycle? If you thought the one on the top was the motorcyclist, then you'd be right. Our motorcyclist checks to the right on approach. When they pull out, they're already looking to see if the motorcyclist is overtaking the stationary traffic. This gives them the most advanced warning that this motorcyclist is going to be a hazard. In contrast, our ordinary car driver was looking to the left, even when the car was pulling out. which means that when they look back to the right, they've already nearly collided with the motorcycle, which they had no idea was coming. Across all the drivers and riders who saw this video, we found motorcyclists spotted the approaching motorcycle sooner than the car drivers. They spent longer looking at the motorcycle than our car drivers, and when this clip was embedded in a traditional hazard perception test, motorcyclists scored more points by pressing the button sooner. And you can see this in the graph on the right. We've turned the scores into percentages, and it's quite clear there that the motorcyclists scored more points on average. So let's return to our question, why do car drivers crash into motorcyclists? We now have our first potential answer. Drivers just don't know where to look for motorcyclists. They've not ridden a motorcycle. They don't know what motorcycles are capable of, and they don't see them often enough on the roads. So it doesn't occur to them that motorcycles might be overtaking or filtering. Let's look at another reason why car drivers might crash into motorcycles, and we'll start again with another activity. I'm going to show you my itinerary for my vacation, and I want to know where and when I'm planning on going on holiday. Now it's going to be quick, you've only got about a second to read it, and it's going to appear in the white segment on the left of the screen. If you said I'm clearly off to Paris in the springtime, then you'd be correct, but did you notice anything odd about that sentence? Let's have another look. Now, some people take a long time to notice this, but actually the word the is repeated twice in the sentence. We don't notice this because we don't expect it. We expect the sentence to be grammatical, and we don't pay much attention to the small words. So even though we're looking directly at the sentence, we still don't see what is actually there. In regards to driving, this sort of error is called a look but fail to see error. These errors can typically occur when we're pulling out of side roads onto a main carriageway. For instance, junctions we're very familiar with, we might expect to be free of traffic at certain times of the day. However, if there is traffic present, we're probably going to expect to see a car, maybe a bus or a van, but we're very unlikely to expect a motorcycle. Again, this is because as car drivers, our experience of motorcycles is very limited. Here's another little activity for you. What word will appear next? If you said cars, then you're correct. But did you spot the finer detail? The letter C of cars was made up of small b's. The letter A of cars was made up of small i's. The letter R of cars was made up of small k's. And the letter S of cars was made up of small e's. If you said the word cars, you did get the answer correct on a grand scale at least. But you might have missed the finer detail that was hiding all of those bikes. The reason this error occurs is because the brain is designed to process bigger things first. As we pull out from a side road, our glance down the main carriageway to check for traffic could be half a second or less. This is enough time to realise that the road is empty, and even enough time to realise that a large vehicle is coming towards us, such as a car or a van. However, it may not be enough time to process much smaller objects, such as an approaching motorcycle. In other words, we need longer to process and identify motorcycles than other larger vehicles. Sometimes even nearby motorcycles might be hard to see. This Think campaign poster shows an approaching motorcycle that's really quite close. However, the background camouflages its approach. If we zoom in, there they are. And now we can see a motorcycle coming towards us with daytime running lights. But they're still very difficult to spot when hidden by the trees in the background. So let's go back to our question. Why do car drivers crash into motorcyclists? Now we have another potential answer. The small size and unexpected nature of motorcycles just makes them harder to identify sometimes, even if we're looking right at them. In fact, both our two reasons for crashes can combine to create extra danger. Let's look at another clip. As we're driving along, we hit congestion. At this point, our sat-nav may advise that there's a faster route using the side road to the right. So off we go, and then almost have a collision with an overtaking motorcycle. Why does this near collision almost occur? First of all, our driver does not expect a vehicle to overtake. They'll be thinking of other vehicles, such as cars behind them, rather than motorcycles. Even if they do look in the side mirror, however, they might look but fail to see the approaching motorcycle. The rider's small and narrow profile might require a longer glance than the driver typically gives to a mirror. This could easily mean that the driver doesn't spot the motorcycle until it's too late. Finally, let's imagine that our car driver does look in the right direction and does identify that the motorcycle is present. Well, there's a third error that they might fall foul of. They might make the wrong decision. To explain how this might happen, let's look at this image showing two approaching vehicles, a car on the left, a motorcycle on the right. The green bars beneath each of them represent the width of the image that each vehicle is projecting onto the back of our retina, which is vital for us to see. Now, as those vehicles get closer to us, their images will expand and the width that they take up on the retina will increase. The red portions of the bar show how much that image is increased on the retina, and in absolute terms, this is much greater for the approaching car than the approaching motorcycle. In fact, in some instances, narrow motorcycles that can be quite far away can quickly get much closer to us, but with only a very small change in the width of their image on our retina. Sometimes its changing width can be so small that it falls below the threshold of what our eyes can detect. This motorcycle can seem far away for quite a while, and then suddenly the motorcycle is upon us. This isn't due to the motorcycle accelerating on approach, but because the narrow profile doesn't expand much on the retina and makes it very hard to judge motorcycles' approach speeds at far distances. So let's go back to our checklist and ask once more, why do car drivers crash into motorcyclists? We can now add a third reason, which is that it can be hard to judge the speed and distance of an approaching motorcycle because of the small image taken in by the eye. This can lead some drivers to mistakenly think they have plenty of time to pull out from the side road, which then leads to a collision. So let's finish with some brief tips on how we can overcome these problems. First, we simply need to learn where motorcycles are likely to come from. The key clues are any line of standing or slow-moving traffic. Motorcycles allow riders to overtake these lines of traffic, so keep an eye out for them. If you ever decide to change your route while waiting in congestion, such as making a U-turn or turning into a side road, look for any overtaking motorcyclists who are, quite legally, avoiding the congestion by overtaking. If you want to avoid the congestion, it's likely that motorcyclists will be thinking the same thing, and these similar thoughts can bring you into conflict. Finally, when changing lanes on multi-lane roads, especially at slow speeds due to congestion, always check for motorcycles who may be filtering between the lanes of slow-moving vehicles. This, again, is a completely legal maneuver, and we need to be aware of this possibility. How might we overcome look but fail to see errors? These are particularly prevalent when pulling out of side roads. So the first tip is always prepare to stop at a give-way line. If this is your default plan of action, then you're much less likely to pull out in front of a motorcycle. Give longer glances down the road. Motorcycles take longer to identify, and if we just give a brief glance to check that the way is clear, we have the greatest risk of missing one. Also, be careful that an approaching motorcycle is not hidden by the background. This could be trees or other scenery, or even be an HGV travelling behind the motorcycle on the main carriageway. If we're not careful, it's possible to look at the motorcycle and the HGV, but only see the HGV. Finally, how might we better judge the speed of an approaching motorcycle? Once you've identified the motorcycle as approaching, don't make any snap judgments about how much time you have to make your planned manoeuvre. Look at the motorcycle for a second longer, and you will get a better understanding of its speed and distance. The safest thing to do is always give way to a motorcycle. If there's any doubt, then don't pull out. And if you think it's in range, then don't lane change. Follow these tips and you will improve your hazard skills and help preserve these most endangered of road users.